Hey everyone, welcome to Tech Adventure. As I promised, we're back with more C programming questions, focusing mainly on structures, unions, enums, and functions. If you missed our previous videos, check them out first as this session builds on them. Whether you're a beginner or a pro, get ready for new and challenging questions. Let's sharpen those interview skills together. If you enjoy my videos, please like, subscribe, and share with friends and anyone seeking this information. Without further delay, let's dive into today's Q&A session. 41. What is a volatile keyword in C? Where is it used? The volatile keyword in C is a type qualifier that informs the compiler not to optimize a variable because its value might change unexpectedly at any time. This could happen outside the program's control, such as through hardware, interrupts, or shared memory. When a variable is declared volatile, the compiler ensures that every access to the variable is performed directly from its memory location instead of relying on any cached or optimized values. Purpose of the volatile keyword is 1. Prevents compiler optimizations. The compiler might optimize code by storing a variable in a register instead of rereading it from memory if it thinks the value won't change. Declaring a variable as volatile prevents this optimization. 2. Used for hardware interfacing. Hardware registers or memory map devices may change values unexpectedly. Volatile ensures the program always reads the current value from memory. 3. Handles interrupts or multi-threading. Variables modified in interrupt service routines, ISRs, or shared between threads must be marked volatile to ensure correctness. Here listed when to use volatile. Have a look. For example, volatile for hardware register. Suppose you are reading from a hardware register, example, a timer or sensor, that changes independently of the program. The volatile keyword ensures that the program always reads the latest value from the hardware register, timer underscore, register underscore address, instead of caching it. Without volatile, the compiler may optimize the loop to read dereference timer only once, thinking its value never changes. Look the difference between const and volatile. 42. What is a structure in C, and why is it used? A structure in C is a user-defined data type that allows grouping of different data types under a single name, making it easier to represent real-world entities. Structures are widely used in applications like databases, embedded systems, and complex data structures. By combining structures with arrays, pointers, and dynamic memory, C provides a flexible and efficient way to manage data. Structure used in C. 1. Group-related data. Structures allow combining variables of different types logically, which helps organize data meaningfully. 2. Improves code readability. Instead of managing individual variables, structures make it easier to handle related data in a grouped manner. 3. Useful for complex data management. Structures are the building blocks for creating more complex data structures, such as arrays of structures, linked lists, and trees. 4. Data representation. They are widely used to represent real-world objects, such as a student, employee, or product with multiple attributes. Here's the general syntax of defining a structure. The struct keyword is used to declare a structure. Includes variables, or members, of various data types. See the example of basic structure. Use the dot operator, dot, to access members of a structure. For a pointer to a structure, use the arrow operator. Here is comparison between structures and arrays. 43. What is a union in C? What is the difference between structure and union? A union in C is a user-defined data type that allows storing different types of data in the same memory location. Unlike a structure, where each member has its own memory space, a union shares the memory among its members. The union keyword is used to declare a union. All members of a union share the same memory location. The size of the union is determined by the size of its largest member. Only one member can hold a value at any given time. Union is used to save memory when you need a variable to store different types of data at different times. In this example, the largest member is int or float, both of which take 4 bytes. Therefore, the size of the union will be 4 bytes here. Here is key difference between structure and union. 44. What is the size of a structure, and how is it calculated? The size of a structure in C is determined by the sum of the sizes of its members, plus any padding bytes added to align the members for optimal access in memory. Padding ensures that data members align to specific memory boundaries, which improves CPU access efficiency. The size of a structure is based on the data types it contains, example, int, char, float. The compiler may add extra bytes to align members to specific memory boundaries. This alignment depends on the size of the largest data type and compiler-specific rules. Most compilers align data members to addresses that are multiples of the data type size. For example, int, 4 bytes, is typically aligned to a 4-byte boundary. See in the example, since the int member must start at a 4-byte boundary, the compiler adds 3 bytes of padding after the char. That's why size of structure here is total 8 bytes. Check out more examples to better understand how structure size is calculated and how padding works. The order of members in a structure impacts the padding and overall size. Grouping smaller data types, like char, together, and placing larger types, like int or float, after them, can help minimize padding and optimize memory usage. 45. What happens when you initialize multiple members of a union? As we know, union allocates memory equal to the size of its largest member. All the members of the union share this same memory. When you assign a value to one member, it directly writes to the shared memory location, overriding any previous data. You can initialize only one member of a union at the time of declaration. If you assign values to different members after initialization, the last assignment will overwrite the shared memory and impact the other members. Accessing a union member other than the most recently assigned one leads to undefined behavior. The data will be inconsistent. Unions are great for saving memory and handling hardware-level programming. However, they come with limitations, such as the inability to store multiple values simultaneously and the risk of undefined behavior if accessed incorrectly. Here's a clear table explaining the advantages and limitations of using unions in C. 46. Can a structure or union be nested? Explain with an example. Yes, structures and unions can be nested within other structures or unions in C programming. Nesting allows you to define one structure or union as a member of another structure or union. By combining structures and unions, you can design versatile and efficient data representations suited for various applications, such as embedded systems and hardware programming. See here different nested examples. 47. What is an enum in C, and why is it used? An enum, short for enumeration, in C is a user-defined data type that consists of a set of named integer constants. It is used to make code more readable and manageable by assigning meaningful names to integral values. Enums help reduce errors caused by using magic numbers, also called hard-coded values, in code and allow you to represent a set of related constants more clearly. See the syntax and example here. To declare an enumeration, you use the enum keyword. By default, the first constant is assigned 0, and subsequent constants increment by 1. Enums can have explicitly assigned values. Enum size is typically the size of an int. Enums are a powerful way to make code cleaner and easier to understand. 48. How does an enum differ from hashtag-defined constant? Both enum and hashtag-defined constants are used to define named constants in C. However, They have key differences in functionality, readability, and type safety. See the detailed comparison. Enum is a user-defined data type that assigns names to integral constants. #define is a preprocessor directive that defines a constant value or macro. Enum values are strongly typed. The compiler can perform type checking to ensure only valid enum values are used. On the other hand, #define constants are not type checked since they are replaced with their literal values during preprocessing. Enum values are easier to debug since they have meaningful names. #define constants only show numeric values, which can make debugging harder. While both enum and #define serve the purpose of defining constants, enum provides better type safety, readability, and debugging support. It is preferred when defining a group of related constants. However, #define can still be useful for simple substitutions and macro definitions. 49. What happens when a function is passed a union? When a union is passed to a function in C, the following behaviors and rules come into play. A union is allocated memory equal to its largest member. When passed to a function, the entire memory occupied by the union is copied to the function, passed by value, or passed by reference using pointers. If you pass a union by value to a function, the entire contents of the union, largest member size, are copied into the function's parameter. You can pass the address of a union to a function using pointers. This avoids copying the entire memory, and instead, the function operates directly on the union's data. When a union is passed to a function, only the currently active member, the last assigned member, holds a valid value. Accessing any other member would result in undefined behavior. See the summary here. 50. What is the difference between inline initialization of structures and functions? Inline initialization refers to assigning values to variables, like structures, or defining functions directly where they are declared. However, there is a clear difference between inline initialization for structures and functions. Inline initialization of structures means initializing the structure members at the time of its declaration. In C, functions can be defined inline using the inline keyword in some compilers, or by defining their body directly during declaration. This provides the function definition within the same place as its declaration. See the key differences. And that wraps up today's Q&A session, part 5, and with that, we conclude our series on C programming interview questions and answers. If you enjoyed the video, don't forget to hit the like button, leave your thoughts in the comments, and subscribe for more valuable content on programming. Sharing this video could help someone preparing for interviews, so spread the knowledge. Stay tuned for our next series, where we dive into C++ interview questions, advanced programming concepts, and much more. Let's keep growing together, one step at a time. See you in the next video.